Welcome to the Learning Corner. Today, we're diving into the intriguing formation of deserts. Have you ever wondered how those vast stretches of barren land, the deserts, came into existence? This fascinating journey explores the interplay of Earth's many components. It all commences with a scientific principle known as rain shadow. This phenomenon occurs when humid winds approach a mountainous region. Subsequently, the moving air elevates and cools, triggering precipitation on the mountain's windward side. However, as the air continues its journey and descends on the opposite, the conditions change drastically. The descending air experiences an increase in temperature, which in turn increases its ability to retain humidity. This transformation leads to drier conditions on the other side of the mountain. This leeward side experiences significantly less rainfall due to the altered atmospheric conditions. The phenomenon, known by scientists and geologists as the rain shadow, often marks the inception of a desert. Its existence is a testament to the complex and fascinating interactions between atmospheric conditions, geology, and the physical layout of our planet. This area of diminished rainfall is the so-called rain shadow, often the birthplace of a desert. But that's only part of the story. Deserts, contrary to popular belief, aren't just created from high temperatures and lack of rain. There's a multitude of factors that can contribute to their formation, and one such factor is the geographic distance from the sea. As one may imagine, the vast oceans of our planet hold an incredible amount of moisture. This moisture is taken up by the winds that blow the seas, saturating them and in turn, bringing rainfall to the lands that these winds reach. However, when a particular area is situated far from the sea, these beneficial moisture-laden winds gradually lose their water content as they travel inland. The further the winds have to travel, the more moisture they lose. By the time these winds reach the far-off lands, they've lost most of their moisture. This lack of in the air leads to minimal rainfall, thus paving the way for arid, desert-like conditions to prevail. Interestingly, another factor that contributes to desert formation is related to sea currents, especially the cold ones. Cold sea currents have a direct impact on the air above them. They significantly cool the air, which in turn reduces the air's capacity to hold moisture. A lower capacity to hold moisture means less rain, and less rain, of course, means more desert-like conditions. This leads to unique deserts forming along coasts, which may seem paradoxical, but is a fascinating testament to nature's complexity. This leads to less rainfall and desert-like conditions along the coasts. Deserts can also be created due to the continental drift, a fascinating natural process that is a slow movement of the Earth's continents over the geological timescale. This phenomenal geological event is incredibly slow-paced, taking millions upon millions of years to effect substantial changes. It's easy to dismiss its significance in our daily lives due to its snail-like pace. However, its effects on the macro scale of Earth's geography and climate are profound and far-reaching. The continental drift shapes and molds the layout of our continents, creating the unique patterns and structures that we see on global maps today. This process, guided by the hidden hands of underground tectonic plate movements, has the power to shift and transform entire landmasses. As it does so, these landmasses drift into regions with specific atmospheric conditions. Consider for a moment a landmass gradually drifting into a region characterized by high atmospheric pressure. These atmospheric conditions are unique, potent, and have the capacity to significantly influence the climate of the drifting landmass. This includes the creation of desert-like conditions, the excessive heat and significant lack of rainfall, characteristic of high-pressure zones, render the once fertile and lush landmass into a barren and arid wasteland. This, in essence, is the birth of a desert, a product of the interplay between continental drift and specific atmospheric conditions. When a landmass drifts into a region with specific atmospheric conditions, like high pressure, it can result in desert formation. Finally, we arrive at the significant impact of human actions, which can incredibly lead to desert formation, a phenomenon commonly referred to as desertification. This is a dynamic process involving a multitude of factors primarily driven by human actions, namely overgrazing, deforestation, and unsuitable agricultural practices. Overgrazing occurs when vegetation is exposed to excessive grazing for extended periods. The overuse of land for animal rearing depletes the ground cover, leaving the land vulnerable to erosion. Additionally, deforestation, the act of removing vast expanses of forest, significantly disrupts the balance of the ecosystem. Forests, being crucial carbon sinks when removed, lead to increasing soil degradation and desertification. Furthermore, poor agricultural practices significantly contribute to the degradation of land. Unsustainable farming methods, like excessive tilling and incorrect irrigation methods, disrupt the natural composition of the soil, leading to decreased fertility and eventual desertification. In essence, these practices can degrade the land, leading to desert-like conditions. In summary, the formation of deserts is a complex process involving several factors. It's not merely about the expansion of sand dunes or a simple lack of rain, but rather a multifaceted process that requires an amalgamation of geological, meteorological, and human factors. Firstly, the concept of rain shadows, or the effect of a higher area of land on the precipitation on the lower area of land, of the significant contributors to desert formation. This aspect creates a region where rainfall is significantly less, leading to arid conditions. Secondly, the distance from the sea matters. Coastal areas, due to their proximity to large water bodies, tend to experience more rainfall. But as we move inland, this precipitation gradually decreases, affecting the region's overall moisture and potentially leading to desert conditions. Thirdly, changes in sea currents, particularly warm and cold currents, can drastically alter the climate of the adjacent land areas. When sea currents shift, they can either bring increased moisture or drive away existing humidity, influencing desertification. The fourth factor is continental drift, gradual movement of Earth's continents over geological timescales. This movement can alter the geographical landscape and climate of a region, potentially turning it into a desert. Lastly, human activities like deforestation, overgrazing, inappropriate irrigation practices, and other forms of land mismanagement play a significant role in desert formation. Such activities can exacerbate the natural arid conditions and lead to more significant desertification. Each desert on our planet has its unique story of formation, a testament to the dynamic and ever-changing nature of our Earth.